In this video, we're going to look at Venn diagrams and use Venn diagrams to look at some application problems specifically relating to surveys. So as I said, we're going to use Venn diagrams to analyze the results of surveys, and we're going to talk about De Morgan's laws and the idea of complements. We talked about how complements and negation are very similar, and we have a De Morgan's laws for set theory, just as we did for logic. But let's start with this idea of surveys. So let's just introduce this problem. We'll talk about how the Venn diagram will help us. So as the advent of Netflix and other streaming services has Netflix and other streaming services affected attendance at movie theaters? To look at this question, a film class conducted a survey of people's movie watching habits. Hundreds of people between the ages of 16 and 45 were asked to complete the following survey. You have to check the box if you've watched a movie in a theater during the past month. Check a box if you streamed a movie at home during the past month. The results of the survey were collected, and it was found that 388 people checked the theater box, 495 checked the, not DVD, that should be Netflix box, the streaming box, 281 checked both boxes, and 98 people checked neither. So first of all, we're going to call the theater box, going to theater T, and the streaming box we're going to call S. So what percent of the people surveyed watched a movie in a theater or streamed at home during the past month? What percent of the people surveyed watched a movie in a theater only and streamed at home only? So this may seem like a very easy problem maybe at first glance. We're just given the numbers and maybe the numbers are just the answer. There's a little more subtlety involved, and that's thinking about the union and the intersection between all of these sets. So let's think about the numbers that we have. Let's talk about how we can use the Venn diagram. All right, so we have that 388 people checked the theater box. So what that means is that in this circle here, we have 388. We had 495 check the streaming box. So that is in this circle, we have 495. We had 281 check both boxes. So what does that mean? That is that they checked T and S. That's the intersection. That means that there are 281. We'll actually put that on the inside here. There's 281 in the intersection between both T and S. And 98 people checked neither. So that is, there is 98 people who are on the outside here that did participate in the survey, but that are not part of either circle T or S. So let's think about what questions we're actually asking. We have all these numbers. We kind of labeled them in the picture. Let's talk about what we're actually looking for. So part A says, what percent of the people surveyed watched a movie in a theater or streamed at home during the past month? So that is, we are looking for T, and then the or is our union. So T union S. Either or. So that's what we're looking for, is what percent of the people surveyed watched a movie in theater or streamed at home. We're trying to find something about T union S. What percent of the people surveyed watched a movie in a theater only? So that's going to be this, we'll just kind of label it in the picture. This little crescent moon shape here is T only. And then we also have this little crescent moon on the other side is S only, which is what we're looking for in part C. All right, so there are, in this picture, there's actually a lot of different things to label. We want to find T union S, T only, and S only. So how can we do that using this picture? Well, we know that there are 388. So let's look at, I'm going to kind of erase some of this stuff real quick. We know that there are, 281 in the intersection here. And we know that there are 388 in T, that circle total. So how many are in the part that doesn't include the 281? Well, we can say that this is going to be the T only is going to be 388 minus 281, which is going to give us our 107 in that little area there. Similarly, we can do this for S only. S only is given to us by, there are 495 that checked S, but 281 checked the other one as well. So this should be 495 minus 281 will give us 214. And then we know that there are 98 people left on the outside. So we can find those T only and S only using some subtraction there. So let's look at this problem on the next page. Same thing, same problem. Note that when we're talking about what percent of people, we're actually looking for the size of these sets, the size of T union S, the size of T only, and the size of S only. That's the cardinal number. And now we know that for T only, we have, this is 107. For S only, we found that's going to be 214. And how can we find the union? Well, we can just add up each part of our two circles there together. That's going to be 107 plus 281 plus 214, which will give us 602. So that's how much are in this entire bubble here in the T union S, which is both circles together. All right, so although that's going to be all the really hard work we have to do, that doesn't actually answer the question, because we are looking for what percent of people surveyed. So it may help to actually answer how many people were surveyed. And this is where our Venn diagram comes in handy, because we've labeled each individual chunk of the Venn diagram. There are kind of 4 spots. There's the stuff on the outside, the stuff in the T only, the stuff in the S only, the stuff in the intersection. So we just have to add up all those numbers. 107 plus 281 plus 214 plus 98. We already did some of that calculation, but altogether this is going to give us 700 people total. So when we answer these questions now, what percent, we're going to take the 602 that we found, that's the number of people, divided by the 700 for part A. For part B, the T only, we're going to take 107 and divide that by 700. And for part C, we're going to take the 214 and divide it by 700. When we do 602 divided by 700, that gives us 0.86. And that's going to give us 86%. Remember, we move the decimal point over 2 spots to get the percentage. When we do 107 divided by 700, we get 0.15, about 0.153, and that'll give us about 15.3%. And finally, 214 divided by 700 will give us about 0.308, which will give us 30.8% about. So it's not enough just to say the numbers. You have to give the percentage by dividing by the total number of people. All right, so let's try this again. This time we're going to have 3 circles involved. So let's introduce the problem, then we'll talk about kind of how to deal with this. So a consumer survey was conducted to examine patterns in ownership of tablets, cell phones, and Blu-ray players. The following data were obtained. 213 people had tablets, 294 had cell phones, 337 had Blu-ray players. We're going to call that T, C, and B, those 3 sets. 109 had all 3, 64 had none, 198 had cell phones and Blu-ray players. Remember, and here we are looking at an intersection. 382 had cell phones or tablet computers, that is, or is a union. 61 had tablet computers and Blu-ray players, but no cell phone. Now we're looking for percent of people surveyed owned a tablet computer, but no Blu-ray player or cell phone, and what percent of people owned a Blu-ray player, but no laptop or cell phone. So here's the strategy. We are going to fill out this Venn diagram and try to label each and every part of that Venn diagram. And how many parts are there? Let's just kind of number them off. We have the outside of the circles. We have inside this chunk, inside this chunk, inside this chunk. That's like T only, C only, and B only. Then we have the ones that are connected to just 2 of them, and the one on the inside. So there are 8 different things that we can try to label in this picture. And if we're able to do that, then we can answer all of these questions. All right, so let's try to label this as much as we can, just with the information given before we get into too complex of things. Let's start with the ones that are kind of given to us just right away. 109 had all 3. I'm going to label that as the intersection in the middle. That is all 3, inside of all 3 circles. Similarly, we can do the 64 had none. That is the outside there. The rest of this is just a puzzle that we kind of need to solve. So for instance, let's look at this intersection between C and B. We are given that 198 had cell phones and Blu-ray players. That's the intersection of C and B. That whole thing is going to be 198, but we're only looking for the chunk that is not in the intersection of all 3, this area right there. So to do that, to find this area, we can do 198, which is going to be in that total wedge, minus the 109, that's in all 3, and that will give us 89%. Right? So 198 is that total wedge, but now we know 89 is that one little piece. All right, let's keep on going, trying to label all 8 of those pieces. We've labeled 3 so far. So next, let's look at this piece of information. 61 had tablet computers and Blu-ray players, but no cell phone. So let's try to think about what piece of the puzzle is this looking at. This is saying that we are intersecting T and B. So we're in T and B, but not C. And that is going to be this little area right here. That's intersecting T and B, but not that C. So just this chunk right here. And we're just given that that's going to be 61. So we've gotten 4 pieces of the puzzle down. Let's see what else we can do. All right. We are given, so let's think about our picture now. So we're kind of jumping back and forth between the picture and the information. And there's not maybe just one way to go about it, just trying to find a way to go about it. So note that at this point, we have all of the Blu-ray circle minus one little piece. And we have that, we know how many people are in the Blu-ray circle completely. So that means that in this piece, we should have the total number of people there, 337, minus all of those other pieces, which is going to be 109 plus 98 plus 61. And if we add all of that together, we get 69 in that little chunk. So again, if you add 61 plus 69 plus 109 plus 89, that's everything in the Blu-ray circle. That should give us 337. So now let's go to the next page. We're going to kind of just think about the rest of the information. We have 5 pieces so far. We just need to fill in the last 3, and then we can talk about our what we're looking for here, A and B. So note that on this page, you've also talked about what this what these sets are, right? Cell phone and Blu-ray players are C intersect B. Cell phones or tablets is C union T. We talk about 61 had tablets and Blu-ray players, but no cell phone. That is T intersect B and not C. So that is C complement. We'll talk about those when we get to the final answer. But let's fill in those last 3 circles real quick. And what piece of information have we not used? We have not used how many people are in T, how many people are in C, and how many people are in C union T. All right, so C union T, let's start with that, has 382. So what piece of the puzzle is this? That is the circle for C or the circle for T. That is this big blob, has 382. So that means that this blob, we'll shade this one, has 382 minus all those other numbers, 109 plus 61 plus 89, which would give us 123. Right, we also know that, for instance, in the cell phones, we have 294 had cell phones. So that's this circle. So that means that this chunk here, this like crescent moon, is going to be 294 minus those pieces, the 109 and the 89. Which will give us 96. And similarly, we can do the T circle total is 213, but if we're looking for just that kind of crescent moon shape, this will be 213 minus 109 and 61, which gives us 43. So those pieces of the puzzle can't give us any of those three places, but together that'll give us the information. So if we kind of redraw this picture, think about what we're looking for. We have kind of like two circles here, just thinking about C and T, ignoring the 89, the 109, and the 61. We have that inside the both circles, we have 123. Inside just the C part, we have 96. And inside the T part, we have 43. So now we can use our kind of counting thing, that is, that the number in C union T is going to be the number in C plus the number in T minus the number in the intersection. And note that the intersection is maybe what we're kind of looking for here. So this little equation we can say this is going to be 123 is equal to 96 plus 43 minus the number of stuff in the intersection. And that means that, we'll do this down here, that's going to be the number of stuff in the intersection is going to be, that's going to be 16. So that means that this area here, that's the intersection that we just found, is going to be 16. So note that there's another way that we could have found that, and I wanted to go over that real quick, and I probably use maybe an easier way of doing it, just to show there's different ways of going about it. Total, so not just thinking about just those things, but looking at the 89, 109, and 61 as well, we could have used that formula. The number of C union T is equal to the number of C plus the number of T minus the number in the intersection. We're given C union T is 382. We're given the number of people who have cell phones, 294. We're given the number of people who have tablets, 213. And we're looking for the intersection. And this gives us that N of C intersect T is 125. And that is the intersection between C and T, but we only want that one piece, so if we subtract 109 from there, we get our 16. That's a little more clear cut to kind of do, but it's to show there's kind of different ways to get to our answer. All right, we can fill in the rest of our circle here, and then we'll answer the questions finally. So note that to find this chunk of T here, getting a little bit crowded, but we'll just shade it in. We can take 382 and subtract off everything else. 109 plus 61 plus 16. And to find this chunk right here, we can do 294 minus the other stuff. The stuff in T only would be 196. And the stuff in C only, we can go 294 minus 16 and 109 and 89 would give us 80. And I made a mistake, sorry. This chunk right here should not be 382. T only was only 213. Minus all of that would give us 27. All right, so let's go to the next page. Let's kind of regroup and we'll talk about answering this question. So here we found all these labels for all 8 parts of our diagram. And to do that, that's a puzzle that you need to kind of put together. You can start with what you know and kind of build all these things using that counting formula that we've used a couple times. Subtracting off what's in common, that sort of idea. And there's not one single way of doing that. Once you've labeled all of that, now we can really answer our question pretty quickly. So, part A, what percent of people surveyed owned a tablet computer but no Blu-ray player or cell phone? And note that that is the set T and not B or C. So that's B union C complement and T intersect that. So let's think about where that is in the Venn diagram. What percent of people owned a tablet? So we're in the tablet computer, but no Blu-ray or cell phone. That is our T only. It's another way of saying only a tablet computer. That's going to be 27. All right, 27 people, but how many people total we'll find in a second. And what percent of people owned a Blu-ray player but no tablet or cell phone? Again, that is just our B only. We found that much earlier here. Just that chunk. So before we answer the question, we need to find how many people total. And that is just adding all of the pieces of our Venn diagram, which would give us 515 if we added all those numbers together. So part A, to answer the question, we have 27 people out of 515 gives us about 0.052 or 5.2%. In part B, we take our 69 in that region divided by the 515, and that gives us about 0.134 or 13.4%. All right, so this problem, it was a lengthy one, lots of different stuff to do, but it's all kind of piecing together that Venn diagram. Once you have that Venn diagram, it's, kind of the same thing we did in the first problem, and it's a fairly straightforward problem past that. So last thing we're going to do in this section is talk about De Morgan's laws. So De Morgan's laws is a way to kind of deal with the negation of sets or the complement of sets. So let's remember that for logic we had, if you had not P and Q, that was the same thing as saying not P and, or sorry, if you had not P or Q, it's the same as not P and not Q. If you had not P and Q, that was the same thing as not P or not Q. We have similar things for intersection and union, and we really just replace the or with the union and with the intersection and the not with the complement. So A union B complement is A complement intersect B complement, and A intersect B complement is A complement union B complement. really the exact same thing as De Morgan's laws as before, except we're just using set theory stuff instead of logic. All right, so let's think about this example here. Our universe is all single-digit numbers, 0 through 9. A is 2, 3, 7, 8. B is 0, 5, 7, 8, and 9. We are trying to find A complement intersect B total complement. But instead of finding that, we can use De Morgan's laws to rewrite this set. And we can write that as A complement complement union B complement. And note that A complement complement is just itself. If you take everything not in A and everything not in A, you should get A back. So this is going to be A union B complement, which is much easier to deal with. So in order to do that, we need to find B complement. So let's do that. That's going to be everything not in B. So that's going to be 1, 2, 3, and 6. We have A is 2, 3, 7, 8, and we're taking the union. So it's going to be in either one of those. So that will be 1, 2, 3, 6, 7, 8. And you could do this without De Morgan's laws. There's nothing, doing that. It would just take longer, a little bit more work you have to do that. All right, so let's look at one more problem here. We have the American Red Cross has compiled a massive database of the occurrence of blood types in the US. Their data indicate that on average, out of 100 people in the US, 44 have the A molecule, 15 have the B molecule, and 45 have neither the A nor the B molecule. What percentage of the population have the following blood types? So note that type O is that we don't have A or B. So this is neither A nor B. And we can kind of find that right from the beginning. That is just going to be our 100, out of 100, we know that there are 45 that have neither A nor B. In our picture, that's going to be our outside here. 45 out of 100, that is 45%. All right, and we're done with that first question, kind of given to us right away. Type AB is going to be our intersection. So now we have to kind of do our little, what we've done in the last few problems. So we know 44 have A, 15 have B, 45 have neither. So we got to think about the union here. So there are 100 people total we're looking at. And if we're looking at stuff in the union, that is, in these two kind of circles together, that is A union B. That's going to be 100 minus that 45, or 55 total. So now we can do our counting thing. We have the number of people in A union B is going to be the number of people in A plus the number of people in B minus the number of people in the intersection. So A union B is 55. People in A is 44. People in B is 15. And we're looking for the intersection. So it's going to be 55 equals 59. That's going to give us that this intersection is 6. So type AB, the intersection is going to be 6 out of 100. 6%. So now let's think about the just the A or just the B. So just the A, think about that little crescent moon. That's just going to be the number of people in A, which is 44, minus that intersection, which would give us 38. This will give us 38 out of 100, or 38%. And finally, type B, similar kind of thing. That's going to be 15 minus 6, or 9. %. And in looking at these numbers should add up to 100, and they don't, which means that we have an error somewhere. That error, right, is here. 44 plus 15 is not 49. 44 plus 15 is 59. Or sorry, which makes this intersection 4. Which is going to change all the other answers as well. This is going to be 11, and this will be 40. And now if you add up all those numbers, you get 100%, which is what we need. All right, so a little algebraic error there. We fixed it. All right, this is a lot of long problems. It's the same kind of idea. You get practice, you get better at it, and doing those 3 together is a long one. You're going to have to do one of those on the homework.